Hey guys, this is Miss Middleton. Sorry I couldn't be with you this morning. Obviously life happens and you get doctor's appointments and you just take what you can get. So, today we're supposed to go over the review sheet number 2 that I gave you guys. So I'm going to go through it as quickly as I can. I only really have 15 minutes on the screencast recorder thing. Hopefully it won't take longer than that, but if it does, you'll see a weird break in the video that I'll post to YouTube. So just work with me. I do want to point out that if you hate the review sheets that I'm giving as you go on, I do want to point out that there is on Schoology, under our Corona Out of School Time, our review folder, there is a APES review book for this year. And if I look at it, it has a ton, it's meant for a 6-week study plan. Obviously, we only have 4 more weeks until our test. So either way, this is still a good resource where it'll give you some information of how you could go about to study. So maybe this week you would do 15 to 30 minutes a day of studying. Next week you might move from 30 to 60 minutes, so on and so forth. All right. And it could tell you, it tells you what FRQs to practice, look over the notes from these units, look at ecology, spend extra time on these subjects. You can use Fast Track to a 5, chapter 9 and 10. That's only if you have that book. If you don't, there's still this Bozeman science videos that he goes through and he records. And then, of course, you can always use the AP YouTube channel to review. That would be helpful too. But this is really nice. It breaks down what the exam looks like, and then it gets into different practices. So, yeah, here's the topic outlines if you're not sure what to study for each thing. And then here's vocab words. It's really nice. Gives you practice FRQs. It's just really nice when it comes to, hey, where can I get all this information in one area, or I think I'm really weak in this area. This packet could be super helpful to you. All right, so I suggest using it. Let me know if you want me to go through and do answers from this with you. It is 56 pages. That's way intense, but hey, the more the merrier, okay? So let's flip over to what I had assigned. 3 consequences of global warming. I have them here. Okay, so looking back at our review sheet, the first thing it says is to list 3 consequences of global warming. One of them is going to be your sea level rise, right? So, come on, baby. Flooding, sea level rise. Another one that we could write down. Let me put it over here so it stops getting angry. You might have the degradation of food and water supplies. And if you think about that, that's going to be primarily because, again, sea level rise is going to change the water level. So you're going to have saltwater encroaching. Ooh, I don't know how to spell that. Coming into fresh water. You might have droughts. You might have, I don't know, more wildfires. So that kind of stuff. Don't like that. Stop. Okay. And then another thing would be there's going to be an increase in diseases. which is kind of scary to think about since, you know, we're in the middle of Corona. All right. And that's going to be primarily because as the earth warms, mosquitoes can survive outside of the normal range. They're going to be able to live in higher latitudes. Yeah, did not spell that right. Mosquitoes. There we go. List 3 things you could do to decrease the contribution of global warming. Improve energy efficiency. If we could do that, that would save all kinds of things. Walk or bike when able to. Save on your transportation. Let's get bigger again. Oh, that made that so angry. Come here. Ooh, that made it even angrier. Here we go. Walk or bike when able to. And then eat less meat. You might have some different things than what I have. That's something that you could email me about and say, hey, I wrote this down. Does this make sense? And yeah, there's tons of options. These are just some things that I had down. So, avoids methane, which you guys know is a greenhouse gas. And then obviously trucking the meat from one place to another is going to decrease CO2. So eat less meat, avoids methane, eat locally. That could be one. Less CO2 from carting it from one place to another. All right, greenhouse gases we all know of. CO2. I just threw one up there, methane. Water is actually a natural one. H2O. And nitrous oxide, so N2O. Ooh, O. If you've got nitrous oxide, which again comes from cars and stuff. Nitrous doesn't like it. Alright, use access to the right to draw the following. Draw a line representing the Earth's atmosphere. So as we get higher, what are the layers that we hit? Obviously, I'm not going to... We're going to do this in red. There's 4 layers, just as a refresher. Ooh, 1, 2, 3, 4. Cool. They would probably look better if you could actually see them in real life. So this is going to be our troposphere. Label each layer and identify where the greenhouse effect occurs. And the ozone layer. Alright, so troposphere. Here we have weather. We just learned about bad ozone and how that can create smog. And this is where we're going to have your global warming. Can I enter? Yeah. Ooh, global warming. Alright. This layer, the layer above, is your stratosphere. Alright, this is where your good ozone is. And then we have the next layer, the mesosphere. You don't really need to know anything about that. It's where meteor showers take place. And then the thermosphere is where Earth's atmosphere is eventually going to peter out. Let me just draw really quickly. This is temperature as you rise from Earth's surface. Temperature is going to decrease. Then it's going to increase. It's going to get hotter because of the ozone here. It's cool off again. It's really cold. And then it's going to get stupid hot as you go out and you're not protected from radiation. Alright, agriculture, we didn't really talk about this. Don't know how necessary it is, but it is 12,500 years ago, approximately. So a man-made product is also known as anthropogenic. All right, human-made. We've talked a little bit about that. If you forget, I always think of anthropology and how that's the study of the humans. So, anthropogenic, human-made. All right. A molecular formula of ozone is O3. All right, in the box below, write out a series of chemical equations that illustrate the destruction of the ozone in the ozone layer. All right, so, ozone layer, that means we're starting with ozone. So let's do it. You're typically going to start with, well, the way to make this equal is I'm going to start with 2 oxygen molecules. Wish I could make that small. Make you little. Yeah, good enough. All right. Go back to 12. Oh my gosh. I have to go back and get that. What you're going to have is UV radiation is going to turn that into... Oh, this is how it forms. Okay, hold on. So up in that layer, I should probably write formation. Formation. All right. You have to have UV light interacting with 3 oxygens, 3 regular oxygens that you're breathing in. All right. It's a natural interaction with sunlight. All right, so I don't know if I can make these smaller. Yeah, that way you know. Boom, got 'em, suckers. Just kidding. All right, and then let's move this. This isn't the formation. Why is it written like that? I don't like that. All right. Break down. Or you can have, so that's natural. And you just reverse it to form it. So ozone and regular oxygen are constantly in the ozone layer creating, being broken down, creating, being broken down. But you can also have it happen where UV radiation plus something, the chlorofluorocarbons, what's going to happen? Chlorofluorocarbons, there's obviously chlorine in that. When light hits the chlorofluorocarbons, one of the chlorines is going to pop off. The chlorine is like a serial dater. It wants to get with everyone. So it's going to try and get with an ozone molecule. And so it's going to snatch one of the oxygens off of, chlorine is going to snatch one of the oxygens. That's going to leave you with regular oxygen that you could breathe, plus ClO. And then what you have is an oxygen's going to come along and be like, yo, that's my girl or boy, whatever. And it's going to take it from the... Okay, so chlorine steals an oxygen from ozone, but oxygen doesn't like it. So if there's just like a free radical oxygen floating around there, which happens quite often, it's going to be like, wait, I want that oxygen. And so it'll steal it back. And so then you're left with O2, So oxygen that we breathe plus another chlorine, which what that means is now it's free to like go and rip up other ozones. Hopefully that makes sense. Why isn't this getting smaller? I don't like it. All right. So that's how the chlorofluorocarbons, the chlorine is the devil. It wants to break up all the oxygens, primarily from ozone, and then it's bad at holding on to its oxygen molecule. Oxygen comes and steals it back, and then it's free to go and grab more oxygens off of ozone. All right, the acronym HCFC refers to hydrochlorofluorocarbon, which is, let me write down this crazy definition. Let's zoom this in. Which is any group of organic compounds that contain carbon, chlorine, fluorine, and hydrogen. It's used in refrigerants and in place of CFCs. HCFCs have a shorter lifespan and are less reactive, or have a less reactive chlorine. All right. So let's move this up so you guys can actually read it. There we go. Nice. All right, identify 3 examples of biotic compounds in an ecosystem and 3 examples of abiotic compounds. All right, so biotic, remember that's living stuff, plants, animals, and let's not forget bacteria. You could have had different things. You could have had more specific examples of plants and animals and stuff. Abiotic. You could have several different. What I had down is soil, water, and let's go with air. Yeah. All right. Complete the following table for these biogeochemical cycles. All right. Let's look at carbon first. Carbon is, can't read my own handwriting. Building block of 4 major molecules. Yeah. Okay. It's the building block of 4 major, that's a big space, of molecules. We'll shorten it down. Building block of molecules. There we go. The largest reservoir is going to be in rock. Methods of transport are going to be gas, sediments, fossil fuels. Those are just some examples. There's more. And then, is it in our atmosphere long or short? It is, or in the cycle long or short? It definitely is long. All right. Nitrogen, or it takes long to go from one thing to another. It takes a while to go from carbon in the atmosphere into rock. All right. Nitrogen is the key component of proteins, DNA, that kind of stuff. Sorry, this stuff, it's so small. All right. It's found 78% of our atmosphere is nitrogen. So that is the largest place that you might find it. You're going to find it through fixation, or they shorten it. So nitrogen fixation, nitrification, assimilation, ammonification, and denitrification. So if you ever see FNAAD, that's what that is. All right. And this cycle is a lot shorter than the others. All right. It doesn't take long to go from one of these phases to another. All right. Phosphorus is used in in ATP. It's in your teeth. Whoa. And basic, it's gonna help out with your bodily functions. You need phosphorus. All right. This is definitely found primarily in rocks. Okay. And an important thing to remember, there's no atmosphere involved in this. All right. It's in soil, erosion. It's going to be a big part of it. And producers are going to store it. Remember, this is one of those things that if algae gets a hold of it, you're going to have a eutrophication. It's going to be a problem. All right, this is the longest of all of them. If it's in rocks, it's going to take longer to get from one thing to another. The water cycle, it's obviously in living organisms. It's the universal solvent. All right, kind of a big deal. Water is, if you didn't know, kind of a big deal. All right. This is primarily found in salt water, or the place we find water the most is in salt water. All right. You guys know precipitation, runoff, groundwater. You guys know the water cycle. That's how it's transported. And then this is super short again. Doesn't take long for a puddle in your front yard to evaporate. All right, write the balanced equations for photosynthesis in the box on the right. So photosynthesis, this is, again, is equal, or I already went through and made it even. So you need 6 carbon dioxides plus 6, let's do plus 6 waters. I can go back and I can make these better. Plus the sun. It's going to give you sugar, glucose, which is what, 6 C2, nope, C6, C6, H12, ooh, and O6, plus your oxygen. That's 6 of those though. Alright, let's see. Can go and make these smaller for you guys. It'd be great if you could not get in my way. There we go. That way you know. There we go. I might cut this out then. If I have the time. All right. Cellular respiration. All right, so you're going to have glucose. I'm going to snatch that from up here. Control C. All right. Plus 6 oxygens. And that's going to give us 6 CO2. It's pretty much this photosynthesis in reverse. H2O plus energy. All right. In lieu of time, I'm not going to correct that because, or the little numbers, because you can see you literally just flip it, but it's going to give off energy. Okay. The approximate age of the Earth. We didn't talk about it. It's something good to know. Will you have a question on it on your test? Probably not. So I wouldn't stress too much about like, oh my gosh, I have to memorize this. Like, I wouldn't worry too much about it. So 4.5 billion years. All right, the following species, a zebra mussel, that's going to be an invasive species. C. Galapagos tortoise. All right, is going to be your endemic species, meaning it's not doing too hot. F. This is annoying. American alligator. That's going to be probably a keystone species. They are actually kind of cool in that way. They create little homes because they dig little nests for themselves. Tiger salamander. That's going to be your indicator. Remember, most, if you're not sure, most amphibians are going to be your indicator species because they spend half of their time in water, half of their time in land. A lot of amphibians, they can take in air through their skin, which will affect them. So, all right. Norway rat, that's going to be a generalist. It don't care. Oh, A. It'll eat anything. In fact, not that all rats are generalists, but with this pandemic, so that means giant panda specialist. We've talked about that quite a bit. In New York right now, I guess rats are eating rats because since there's no people out and about, there's no extra food and trash lying around that the rats can eat. So I guess they have seen several cases where rats have been duking it out in New York and eating each other. So that's pretty crazy. All right. Anything you need to know about them? Not really. You do need to know all of these key terms, so just make sure you know them. Go through and review those. Biodiversity. All right. Variety of different species, genes, ecosystems, and functions. All right. Define the term biome. All right. Terrestrial regions inhabited by certain types of life, especially vegetation. All right. What? Here we go. And then it asks us to sketch something. So the equator, that's going to be obviously right in the middle here. Ugh, just want to make sure. Oh. Someday I'll get a straight line going. Alright. Equator. Alright. So that's going to be in, the middle there. The Tropic of Cancer and Tropic of Capricorn. That's going to be at, let's do this. So if this is 0, I should have typed that. You're 25 or 23.5. Come here. Do it like this. It's going to be somewhere. Hawaii is actually just a little bit above that. Oh, come on. Someday I'll make straight lines on a computer. Alright, so we are the Cancer and Capricorn is down here. Come on now. Alright. So let's label that. This is Cancer. This is Capricorn. Alright, you want the mid-ocean ridge. Ugh. Alright, we'll do that in black. The mid-ocean ridge, remember, is a divergent boundary. It goes through Iceland here. It's like a big scar where the land is ripping apart underwater. Alright, so that's our, let's do that. Mid-ocean ridge. Alright, location of suppressed upwelling characteristic of the occurrence of an El Nino. So, they didn't label it here, but we all know it's off the coast of Brazil here. Okay, so I'm going to put it in blue. Like what? Thought they put it right there. So off the coast of Brazil, or not Brazil. So here we have suppressed upwelling in this area close to the equator. All right. When there's an El Nino event. All right. This is gonna get a little messy. China is obviously over here. I'm sorry. I'm real sorry how gross that looks. Alright. And then, so we got China, India. Let's do a different color. Purple. India. It's all up in here. You didn't know. Now you know. Alright. Ethiopia. I love Ethiopian food. You've never tried it? There's an awesome place over in Lancaster called Awash. And it is the coolest. They do like family style. You're eating with your hands. It's really crazy. The bread is kind of bitter, but I like it, so I'm okay with it. Alright. Bangladesh and Fremont. Oh, Fremont's a joke. That's what they typically use for, I was like, why is that familiar? But I don't know where that's at. Fremont is an area, not an area. It's a fake place they use for their, all of their environmental science FRQs. So if they're talking about a place and they don't want to use a real place, they will make that up. All right, over here is Brazil, which for some reason is labeled on this. All right. Oh, Bangladesh is in this little nook right there, in case you didn't know. So you need to know Brazil. I don't know why I colored it, but I did. So, China. Okay. You didn't know India. You didn't know Bangladesh. You didn't know Ethiopia. Ooh, come on now. And then, let's trash that. I don't like it. All right. So, those are the things that wanted you to know. All right. Or label on here. Onward. We're almost done. All right. Complete the following table. Let's do it. Tropical rainforest is going to be, guess what, in the tropics. The temperate deciduous forests are going to be outside the tropics, but not at the poles. Taiga, or the borealis forest, is going to be northern, northeastern America, North America, and Eurasia. Tropical grasslands, like the savanna, are going to be in the tropics. We're typically going to see them in Africa, South America, and Australia. Prairie, grasslands, outside of tropics, but not polar. Tundra, northeastern North America, and again, Eurasia. So way up in Canada, way up. Deserts, tropical, temperate, and polar, believe it or not. Just depends on how much rain there is. All right, typical climate. You're gonna have steady high temps, lots of rain. For a deciduous forest, like where we are, there's defined seasons and moderate rainfall. It's not too crazy. Taiga, oh, stop, is going to have cold temps, lower rainfall, tropical grasslands. Come on now. You have steady high temps, but there's clear, rainy, and dry seasons. Temperate grasslands. Again, you're going to have defined seasons, and moderate rainfall. It's just less trees, I guess. Tundra, it's cold, low rainfall. And then in the desert, tropical, it's hot but dry. Temperate, it's moderate but dry. And then, of course, guess what? Polar, cold but dry. All right. Some examples of plants you might find here. Zoom in, gross. You're going to have a dense canopy. All right, lots of huge trees. All right, you might have chimpanzees, toucans, frogs, cheetahs. All right, temperate deciduous forests. You're gonna have broad-leaved trees that are obviously deciduous, so it will lose its leaves. The animals you get here: hawks, deer, foxes, owls. Think of anything that we can see. Plants for taiga or boreal. You're gonna have your conifers / cone-bearing trees. And then animals, you'll have things like moose, fox, and lynx, and bears. Your tropical grasslands, you'll have tall grasses, surprise, surprise, and trees, just some, not a ton. They'll be spread apart. You'll have lions, giraffes. Is that how I spell that? I'll abbreviate. And elephants. All right. For temperate grassland, you will have short grasses, animals, you'll have things like prairie dogs, wolves, rabbits, that kind of stuff. Tundra, come on now. There we go. Tundra, you're going to have grasses and low-growing plants because they're not getting a lot of sunlight, so they can't grow super big. And then you're going to have things like polar bears, seals, foxes, or, yeah, Arctic fox, which are a little different than ours. Come on. Come on. And then deserts, you're going to have succulents. And then animals, you're going to have lizards and heat-tolerant animals. Or tolerant in whichever way, whichever one they're in. You're not going to have a ton of animals there. All right, last two questions. Describe the circumstances that result in cultural eutrophication. We've been talking about it since day one. All right, so extra nutrients enter water, the waterway, usually by runoff from farms, golf courses, etc. And it's usually nitrogen and phosphorus. All right. 2, you have excess nutrients cause algal blooms. Then 3, algae decomposes. Bacteria proliferate to break down the decaying organic matter. It's with 2 T's. And then the bacteria uses all of the dissolved oxygen during respiration, creating a hypoxic environment, which kills fish. Not the right word. All right. Explain the increasing concentration of carbon dioxide in the atmosphere leads to ocean acidification. All right. So we did not talk about this, but if you take carbon dioxide and you add it to water, that's going to create hydrochloric acid, which is H2CO3, carbonic acid, and this can cause coral bleaching, death of marine life, and amplifies climate change, and it can kill phytoplankton, which is our biggest source of taking in carbon dioxide, carbon sink. Okay, that was extremely long, and I apologize, but you have the answers now. Hopefully you found it a little helpful, or at least you could check your answers. Yeah. Have a great day. Email me if you have questions. Bye.